Alright, let's do another video. Just a test, because my fucking video yesterday did not work. I don't know why OBS was being like that, so good now. But if you guys didn't know what problem I was solving N Queens, the first version, but there's an N Queens 2, so let's do the follow-up. Puzzler's problem is placing N queens or an N by N chessboard where no two queens can attack each other. So the previous one was generate them as a list. And this was my solution yesterday. Alright, generate them all as a list, but there's one, two, so there's one, two, there's two possible solutions. Okay, so it's literally the same problem, and it's actually a good idea, good thing for today since I wasn't able to share the code yesterday. Code is pretty similar, I think. Maybe I could do some optimizations instead of using a list. But anyways, Happy New Year's. Today is January 1st. I think literally I have 14 more days, or 13. January 13th is basically an anniversary for this channel, or like at least posting the videos. So, excited for that. Anyways, let's get into it. Idea is keep track of where each queen is placed, what row, what column, which diagonal. Right, we'll call it diagonal and anti-diag. I called it diag 1, diag 2 last time. So anti-diag, right? What column? And this time, instead of generating a list, we will just, instead of using a list, we will count. We'll count. Let's count solutions. So yeah, let's do this. Let's do def backtrack. We'll do rows, calls, diags, anti-diags. So let me think about this. So base case is, how do we know when we're done? That we know, oh, I need to know the current row actually. Current row. Base case is, we'll do also, is the current row we are on is equal to n. Right, the way we use backtracking here is just basically we're gonna call backtracking calls to every function by passing in the next index to process. And so we go through every index, and for every index we'll go through each column, right, and check if we're able to place a queen down there. How do we do that? Obviously we check if the row is there, the column is there. Check if the row, column, diagonal, and how do we calculate the diagonal? I think it's row plus diag, and then row minus diag, or not diag, a column. Right. So the reason why we do this is so we can group them properly, right? So for example, the diagonal is going from left to right here. Go here, 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 here. So if we do the math here, this is row minus row, let's say this here, all of these numbers on this diagonal will be in the same group, right? So anybody who's been placed here will mark themselves as taking up this entire thing, right? So for example, so we're just saying these are a set of all collected diagonals for this row, so, or this diagonal. Same for this way, the math is the same, but it's just the inverse. Actually, I got this wrong. I believe this is row call minus that, and then like that, because the anti-diagonal is the other way, so right to left. So to prove it, going this way, like this. So for example, this will be in the 0 0, this will be the 1 0 ones, right? This is 1 plus 0, this is 0 plus 1. They're in the same group, so that's why we did the math like this. And then we'll just actually, since we're gonna return an integer, I think we can just call backtrack directly, and we're gonna return the solution, or like return the integer instead of the list. So backtrack will obviously start at index 0, and we'll start with set for every single one of these ones. We will only want one queen per diagonal, plus for one of them for each of those, pretty straightforward. So base case is super simple. I think we just say if the cur row equals n, that means we have visited every single row on this matrix here. Yeah, we've visited every single row in this matrix, so that means we've made a solution, so we can obviously return probably 1, I guess. Yeah, we can probably return 1. Yeah, just return 1, that's one solution. Yeah, okay, anyway, that's what I'm thinking right now. Anyways, let's process the analysis, not the base case. Now we need to go through every single column in this row. So for every call in range from n, right? So simple for call in range of n. So we'll go through every single value in the here, and then we're gonna check. We're gonna check if. So first off, we're gonna just skip it if the cur row in rows, or call in calls, or row plus call in diags, or row minus call cur row, cur row, and then in anti diags, right? Let me shrink this so it doesn't wrap so much. Let me make this prettier, so we'll do like this. Right. So if the curve rows in that, and the calls in that, then we'll just skip this one, right? We'll skip this column, right? Otherwise, if you're a possible answer, we're gonna take one that we do take you and one that we don't. So we'll do the one that let's say we want to take this one, right? Right? We do want to take this one, right? We'll try generating all the possible solutions first where we take this one. Yeah. So anyways. Yeah. So we do that, and then we'll actually keep track, we'll actually backtrack with the cur row plus 1 with rows, calls, diag, anti-diags, right? We'll call it like that. We'll cursorily call it like that, and yeah. Okay, anyways. First I need to do some altering, so we need to first rows dot add cur row. Right, well, then we're gonna do some calls here. Add the call. Then we're gonna add the diagonals by calculating the sum, or yeah, the sum. So cur row plus call, and do this inverse for the anti-diagonal. So cur row minus call. Inside that x. Okay, simple. Then we pass that in, and then we want to do a case where we undo it, right? We'll do remove. Move. And then we want to act like the case where we don't use it, you know. So like this is the scenario where we do add it, and then we're gonna add a scenario where we don't add it, where we skip it, and then we do add this instead, you know. After that, I actually want to return the sum of the count, right? Maybe I think I'm +1 here, right? Because I'm including myself as well. Well, I'm not sure exactly. Well, let's try this for now. So yeah, this should be the solution. It's pretty simple, actually. It's pretty easy. Honestly, I'm more of like a medium. Maybe I can just make a count outside. A little better. So if I do an off by one, that probably fucking sucks there. Okay, that sucks. Okay, I think I'm miscounting this. So if the current row equals n, I think there's probably more things I need to do here. Okay. That is one solution, right? I have to also count. Maybe I should just. No. I'm pretty sure. Okay, why am I adding one here? I feel like I'm resetting all the time. Wait, this doesn't make sense at all. Oops. Oh, let me increment this. Yeah, I should increment all the sums. So like, I don't want to replace it with one. I want to add like that. And also, for every function call you do, it should return like it's healthy. Like, if you finish, either you return nothing or you return one, right? You want to bubble that. You want to bring that back up. You know, once you backtrack. Yeah, perfect. All right, see you guys tomorrow.